Hi guys, it's STEM day, so I just wanted to give you the short passage that you're going to be using to answer these questions later because the questions are very much a part of your STEM day group activity. So we're going to start right here and we're going to start with this passage. You can see right here, there's some really cool kites that you can see on this picture, but we're going to start reading about them now. March winds are ideal for kite flying, not just for fun, but also for meteorological purposes. The first experiments with kites were carried out in Glasgow in 1749, when two students used them to measure the temperature at high altitudes. Benjamin Franklin's 1752 kite experiment with lightning is well known, but weather kites became popular for the less hazardous and more mundane tasks of daily data gathering for many years. Of course, balloons were also used to carry instruments aloft, but kites are cheaper, simpler, and much easier to handle in high winds. By 1899, the US Weather Bureau had 17 kite stations. Wow. Each of which regularly lifted instruments to 8,000 feet using a train of several kites joined together. The standard moderate wind kite was about 2 meters by 2 meters. Light wind kites were used when the breeze was less than 8 miles per hour. And guys, if you didn't know, MPH stands for miles per hour. It's an abbreviation. And heavy duty ones when it was above 30 miles per hour. The kites were of the box design, made of spruce and cambric cloth. Piano wires were also used for kite string, and kite trains needed to be hauled back to the steam power windlass, housed in a reel house mounted on a turntable to face into the wind, meaning that the turntable basically means the house can change which direction it's facing based off upon the wind, which is kind of what this is saying. I know that's worded a little bit strangely, but that's just what it means. Each kite train carried a meteorograph, a combined instrument package which recorded temperature, wind velocity, humidity, and barometric pressure. Barometric, sorry guys. While weather kites have been largely superseded, they still have their uses and are still employed by the British Antarctic Survey. So while we have stuff that we use more so today than kites, they are still super useful and can get super important information. And the source for this information was a website called theguardian.com, and it was written on March 24th, 2011. But there's still very much valid information in there. Let's move on to explore. A kite is pushed up into the air by the wind. That's important. Try flying a kite on a still day. It won't get very high before it drops back to the ground. When the kite is flying and there are several forces at work, the force from the kite string pulls the kite forward and downwards. The force of the wind and lift around the kite pushes the kite upwards and backwards, and the force of gravity pulls the kite straight down. The kite climbs into the air when the force of wind and lift pushing it upwards is greater than the force or the pull of string and gravity. The force of wind will be greater when the kite is on an angle to the wind. The force of gravity will be less when your kite is made from lightweight materials. Why does a kite need a tail? This is a very important question. Try to fly a kite without a tail may result in the kite spinning and rolling a lot because the kite is unstable. And if it's unstable, that means it's not able to fly like you see those kites flying in movies. That movie picture image. A tail on a kite helps to provide a drag and stabilize the kite. The windier the weather, the longer the tail may need to be. You can even add more than one tail. Experiment with the length of your kite tail. So that's something to think about while you're making your kite, because today you're going to be making a kite. We have from 7:40 until 9 o'clock. So at 9 o'clock, all of this has to be done. So this isn't something where you can sit and make sure and waste time. We only have a little bit of time, and I want to make sure you do this and you get it done correctly, because I want you to be able to fly your kites. So you can't do that if you're not properly flying or following along. The recall phase right here is recall all the important information from the reading. How might this information be used to help you design your own kite? So you're going to think about what I just read and what you can reread in the passage on the paper that I'm giving you. When you read that, what's important? I just want you to write one or two things down here. You don't have to write the entire passage. Just summarize the important information, okay? Then we have the planning phase, which is gathering supplies, which you have been given supplies. Let's thank Miss Robinson for those supplies. The wonderful Miss Robinson has helped us plan all of this cool stuff. Your supplies will be paper, some little wooden dowels, colorful tape because we love colorful, 2 embroidery floss strands or strong strings, scissors, and a ruler. Our design instructions are right here, and you can read those independently to yourselves. But make sure when you read the design instructions that you're reading them carefully. If you don't read the instructions, typically I've learned, especially with our group right now, if you guys don't read instructions, you're not following along and you don't always get things right. So I want you to make sure you're following these instructions. Check off step 1 when you're done. Check off step 2 all the way to step 9. Do not let yourself go through this and get to step 9 and be like, oops, I forgot steps 4, 5, and 8. That won't end well, and I don't know if your kite will fly, and I want it to be able to fly. So read the steps, check them off when you're done. The testing phase. This is when you let the kite fly and see if it can fly. Now students will have the ability to fly their kite, and then you're going to answer the questions. Well, did your kite fly? Why or why not? If you didn't fly, it's okay. Give me your thinking on why it didn't. Compare your flight or the flight of your kite to someone else's in the classroom. How does it compare? We've been comparing all week, guys. So make sure when you're comparing, you're able to see the differences. How was it similar? How was it? And also tell me how it contrasted one another. How was it different? Did someone's kite fly less? Someone's kite fly more? Did it fly higher? Did it fly lower? Give me your comparison and contrast. Important are in the improvement phase. What changes could you have made to make it better? What changes could have been made to your design to make it stay in the air longer? If you were to redesign, what would you do? Well, how would you and your team change the design? Now is the explanation. And again, this is all a part of that 7:40 to 9 o'clock time. Create your own definition of meteorology. And this is something where you can use Google to help you out. What does meteorology mean? But I want it in your words. This is very much a paraphrasing activity right here. Then explain how kites were used in meteorology. Again, I want it to sound like you. I don't want to hear an article's voice. I don't want to hear an author's voice. I want to hear my student's voice. The third one, what factors impact the flight of a kite? So what makes it fly? What makes it not fly? You can refer back to the passage. You can refer back to this video. You can go to our dear friend Google, whatever you need to answer these questions. In addition to the study of meteorology, what could be other uses for kites? The last parts are these two: evaluate. So when we're evaluating, we want to have it 6 to 8 sentences, which is going to be our paragraph. Tell me what you learned. How did today's kite design STEM activity relate to what you've learned in class? And this can be science class. This can be reading class. This can be any class that you have had this year. How does it relate to the other topics in science? And then extend is research the use of drones. Compare and contrast how the use of drones And kites and signs are both similar and different. So again, going back to that beautiful language arts standard of comparing and contrasting. How are they similar, which we know similar is comparing, and how are they very different? Remember, different is contrasting. So go ahead and answer this, fill out your paper with your group. Make sure, remember, I throw away no name papers. Make sure everybody's name is at the very top of this. I should have everybody who works. If you have a group member in your group that decides not to participate, their name does not go up here and they will not get the credit for this. But everybody who does needs to have their group name at the top of the paper. Bye, guys.